Hi everyone, previously we discussed DICOM and we have seen that DICOM is based on two things, on DICOM file format and DICOM network protocol. In today's video we will focus on the handling of DICOM files. There are many software and applications that are used to manipulate and display DICOM images. You can simply search for DICOM viewers on the internet and you'll find many examples. I have here, for example, Radiant DICOM viewer. That's a DICOM viewer that give you the ability to display your DICOM images. There are also many libraries developed for a variety of programming languages like Python, Java, or C++. They can be used to manipulate DICOM files. Okay, in this short video we will see how to use Python to manipulate DICOM files. And in order to do that you surely need Python with a Python IDE. I'm using PyCharm here. You can use whatever you want, and in addition you should install pydicom. And in order to do it you will just simply write pip on your terminal, write pip install pydicom. Okay, I have already installed it. So here the requirement is already satisfied. I can move to the next step. Here I'm going to import pydicom simply. It would be better to make your code on a virtual environment. That will prevent breaking your other projects in case you needed to upgrade the package. I'll try to keep these things as simple as possible. Even if you have no coding experience, you can easily understand what we're doing in this tutorial, okay? In order to show you how to read and handle DICOM images, we need first some DICOM files. You can download them from internet. You can find many datasets available on Kaggle website. You should look for Kaggle competitions. Or simply, like in this little tutorial, we can use the images included in pydicom. If you come here on the library, the pydicom library, I'm gonna come just try, where is the pydicom? It's right here, and I'm gonna look for data, then test files, and here there are many test files that could be used for learning how to handle DICOM files. You can see here the DCM extension. Okay, so we're gonna pick one of these. Let's pick one of these images and read its content. So here I'm gonna write file path, and then I'm gonna use a method that I'm gonna import from pydicom library. So I'm gonna write here from pydicom, and then dot data. Okay, import get test data file. That's it. This method is simply gonna give me the file path of my chosen file. If, for example, I'm gonna write here get test data file, and I'm gonna give the name of one of these files that I'm gonna use. For example, I'll take this MRI small DICOM file, mr small dot dcm, and then I'm gonna print file path and show you what it gives. Here I'm just getting the file path of our chosen DICOM file. We have to pass this file path to the DCM read method. I'm gonna write ds equal pydicom dot DCM read, and then I'm gonna give it the file path. Okay, then I'm gonna print ds. And as you can see here, DICOM read will read any DICOM dataset stored in accordance with the DICOM file format. If you are using a DICOM downloaded file, you can pass its path directly to the DCM read method. And don't forget to add the R prefix. For example, I'm going to give you an example here. I'll take this path. Let's assume that this is the path of your downloaded file. I'm going to just put it here, and with adding this R prefix in order to ignore all the escape codes. Or you can simply remove this R and add double backslashes in order to read the path the right way. Okay, so I'm gonna run it and see that it's correct and that it goes right as expected. So this is the right method in order to display the content of your DICOM images. Okay, so I'm gonna just let it file path, and you can see here that you can view the content by using the print ds. So as you can see here, each DICOM has a tag that uniquely defines that element. And this tag here, these two elements, these two numbers, is composed of two short numbers called group and element. Here on the second column, these are effectively the names of the elements, and those two characters are called value representation, or VR, and they describe the data types of this element. For example, UI is for unique identifier, CS, for example, is for code strings, DA means date, TM means time, and so forth. Okay, so the column on the right contains the value stored in that specific element. That's obvious. So for all element categories, we can access a particular element in the dataset through its tag or by using keywords. Let's give you an example. If you want just the patient name, for example, so I'm going to remove this. I'm going to get the tag for the patient name. For example, here we have the patient name and its tag is 0010 0010. Okay, so I'm going to just remove this and write here print, and then ds, and then I'm gonna write 0x for hexadecimal, and I'll give it the code for the patient name, and then another ux, and then 0010. Okay, here we go. We have the patient name here. If you want just the value, the content of this element, you can just add dot value here, and that's gonna give you the value of your element. Another way of accessing elements is by using keywords. What are keywords? Keywords are usually the same element's name without spaces. You can find a list of all keywords on DICOM standard documentation. I'm going to give you an example here. For example, if I want to print the patient name, and then I'm going to write patient name, and you can see here that will give you the patient name. If I want to reach the value element of your patient name, for example, I can write ds dot patient name. It's more practical, and you can see that's gonna give you the value of your patient name. For other variables, for example, print ds dot modality, for example, you can see here it gives you, this is the MRI modality. Another useful information, for example, like the manufacturer, for example, and you can see here you can reach, this is a Toshiba equipment, you can reach whatever you want. So this is how we can reach specific data on your file. Now let me show you how you can handle sequences. What is a sequence? Let's look for it here. I'm gonna print, let's remove all of this and just print the whole file. I'm gonna look for a sequence. We don't have a sequence on this file. I'm gonna use another file here. You can see it just right here. This is a CT file, CT small DCM, and then there is a sequence. Yes, it's here. We have a sequence here. You can find, you can see here this space or this indentation, which means that this element, other patient ID sequence, contains many elements. It's like parent-children relationship that we find in tree dataset structures. Okay, so here, for example, you can see this other patient ID sequence, and we can use it in order to reach its specific content by using the Python list methods. How we can do it? Simply, I'm going to write here, for example, print, and then the ds, for example, dot other, that's the sequence other, and then patient, and then ID, and then sequence. Okay, and in order to reach the first element, I'm going to use the 0 index. The first element is this element here that contains this A, B, C, D, 1, 2, 3, 4, and this other element, second element, contains this 1, 2, 3, 4, A, B, C, D. Okay, so in order to reach this first element, I'm going to give it the 0 index, and I'm going to run it and see I have made a mistake somewhere. It's other patient, yes, it's other patient ID. Okay, and then I'm gonna run it. Okay, I'm gonna remove this in order to see it clearly. It's here. So this is the first element, as you can see, and in order to reach the second element, I'm going to just give it 1 here, and it will print or display the second element of my sequence. Okay, that's it. That's all about sequences. What about the image itself? Here we're gonna need the pixel array. How to read the pixel array? You know that an image is equivalent to a matrix or a 2D array where the value of each element is equivalent to the pixel density. Okay, so the image array can be seen by using the pixel array attribute, simply by printing using the same method, print, and then write ds dot pixel and then array. Okay, and then you're gonna run it. Yes, I've made a mistake here because I deleted my object. ds equal pydicom dot DCM read and give it the file path, and then run it, and that's it. That's our image. That's our matrix, because an image is a matrix, as I said before. And you may have a problem displaying this image if you haven't the NumPy library on your laptop. NumPy is actually a library that handle multidimensional arrays and matrices. And in order to install it, you should just write pip, for example, pip install, and then NumPy. I have already installed it, so I don't need to do it again. Okay, so let's get back to our matrix here. So that's our array, the array of our image. What we have to do here is to transform these numbers into something more visual, how to display the image in a real format. And to do so, you have to use another well-known library called matplotlib. And that's why you should come here and print pip install matplotlib. I think I have already installed it, so it won't be reinstalled again. Let's see. Yes, requirement is already satisfied. You should install this library and then import it right here. So we're gonna write import matplotlib.pyplot, okay, as plt. It will be more handy to call it just as plt. And then we're gonna use it plt.imshow. That's the instruction to show your image. And then you'll give it the pixel array of your image, ds.pixelArray, okay. And because your array is a medical image, you have to use a color map, a grayscale color map that will display your image in grayscale. Okay, so we're gonna use cmap here, and then you're gonna write plt.cm.gray, and then you can write just after that plt.show in order to show your video and your image. Show, and then that's it. And here we go. This is our image. This is our CT small image. Let me just end this video by showing you how to edit DICOM files. It's just like changing the value of any variable. For example, let's change the patient name. I'm going to remove all of this, and I'm going to come here and write ds.patient name equal, then write, for example, Amin, for example. And then I'll come here and print the same information. Print ds.patient name, okay, and see how that's gonna change the patient name of our file. As you can see here, that displays a meme. Okay, another thing is to save your image. You can write ds.save and then as, and you can write here the path of your where you're gonna save your image. I'm gonna, for example, just put it on my desktop, for example, and then I'll call it, for example, RM. This is, or CT. This is a CT exam .dcm. Okay, and then run. Okay, that's it. Let's look for it. It's right here. I can for example, here I am accessing this image by using the Radiant viewer. you'll come here and show DICOM tags, and you can see all the information that we've displayed before using Python. You can look for the patient name, for example. It's right here, and it's Amin. We've changed this specific element of our DICOM file. Okay, so that's it for this video. In the next video, we will explore how to communicate between DICOM applications. See you next time, and take care.